Okay, welcome. This is part one of lesson 3.2 in our linear functions unit. So first, our content objective for today is to understand the intercepts of an equation and how to find them. Okay, so the first example we have here is, can you find 20 solutions from this equation? All right, and you don't have to do 20 if you don't want to go that far, but I would like you to try out a few. So for example, if I wanted to find some different examples of x and y, all I need to do is just start inserting values into x. So for example, if x is 0, 0 times 0.5 is 0, plus 2, we're going to have 2, so y will be 2. Okay? If x is 1, 1 times 0.5 is going to be 0.5. Add that to 2, y is going to be 2.5. Last example, if x is 2, 2 times 0.5 is 1. 1 plus 2 is 3, so y is going to be 3, and so on and so forth. And any of these points would all be coordinates on the same line. Okay? So now let's solve for two specific solutions, x and y intercepts. So down here we've got some examples for a, b, and c we'll get to in a moment. Find the x and y intercepts of the following equations and then graph them. So it's pretty simple when we do these. So for example, anytime you want to find the y intercept, which I'll abbreviate, the y-intercept is always going to be when x is 0, what would y be? So I can just put 0 in for x. 0 times 2 is 0, and so y is negative 6. So the coordinates of the y-intercept are 0 and negative 6. For the x-intercept, it's pretty easy. We've got the equation y equals 2x minus 6. If we want to find x, the x-intercept is going to be when y equals 0. So we can put in 0 is equal to 2x minus 6 and then solve for x. And if we do that, we see that x is equal to 3. So the x-intercept is going to be the coordinate 3, 0. Okay. Let's look at our next example. This one's a pretty simple one. Y equals x. So if y is always equal to x, then that means that 0, 0 would be the y-intercept, and 0, 0 would also be the x-intercept. They are going to be absolutely the same in this case. Same coordinates are both the x and y intercepts. All right, let's look at question C here, or problem C. 2x minus 3y equals 12. Well, if we want to find, again, the y-intercept, all we need to do is put in 0 for x. So I'm going to put 2 times 0 minus 3y equals 12. And then I'm going to rearrange the equation, solve. Let's see, 2 times 0, obviously 0. So I've got negative 3y equals 12. I can divide both sides by negative 3. And so y will equal negative 4. So therefore, the coordinates for the y-intercept are 0, negative 4. And now I can do the exact same thing for the x-intercept, only this time I am now going to substitute 0 in for y. So I've got 2x minus 3 times 0. That's going to be equal to 12, which means 2x is equal to 12. Therefore, x is going to be equal to 6, and the coordinates would be 6, 0. And both of these coordinates are on the same line.